Good morning, everyone. Sorry I'm not there. I will be back next week. I just wanted to give you a quick kind of summary of the lesson that we are going to be going over today. We're just going to kind of build off of what we did last time. So what I'm going to do is go ahead and share my screen. And now what I'm going to do is kind of walk through the idea of a derivative again, just so what we really need to know about a derivative is this. It's basically finding the slope of a line, a slope of a curve at a given point. Okay, so what we're going to be working with most of this year is this idea of a derivative. So this guy, f prime of x equals the limit as h approaches 0 of f of x plus h minus f of x. All of that's going to be over h. So this is kind of our definition of a limit. What it means is as we get closer and closer to a point, so as that h gets really, really close to 0, so we're, in essence, we're moving very, very close to x. So it's like x plus just a little bit. So what we're saying is if we kind of started, imagine we have ourselves a parabola, and our parabola looks like this. And let's just say that that parabola is f of x equals 1/2 x squared minus 1. What we're saying is like we're going to look at any point on this curve, and let's say if this is our x point, that's our point x, we're going to see what happens to the curve as we move just very slightly up or very slightly down, either way you want to think about it. So the idea of a derivative is what I'm going to do again is I know that f of x is 1/2 x squared minus 1, and what I'm going to look at is what is f of x plus h. So what I mean is I'm going to go ahead and substitute x plus h into this. So it's going to be x plus h, the quantity squared, I'm sorry, 1/2 x plus h, the quantity squared, minus 1. And then I'm just going to expand everything out. This is going to become 1/2 x squared plus 2xh plus h squared minus 1. So now what's going to happen is I'll just kind of expand it out, 1/2 x squared plus xh plus 1/2 h squared minus 1. So this first piece, this f of x plus h, becomes this quantity 1/2 x squared plus xh plus 1/2 h squared minus 1. And so that is this piece right here. And then what I'm going to do is I'm going to substitute in this 1/2 x squared minus x for f of x. So minus 1/2 x squared minus 1. And that whole thing is going to be divided by h, and that's the limit as h approaches 0. And then I'll just go ahead and simplify it. So again, limit as h approaches 0 of 1/2 x squared plus xh plus 1/2 h squared minus 1 minus 1/2 x squared plus 1. And that whole thing is over h. And if you look at it, the 1/2 x squared, 1/2 x squared, they cancel out. The negative 1 and the positive 1, they cancel out. And I'm left with xh. So I'm left with the limit as h approaches 0 of xh plus 1/2 h squared. And that whole thing is over h. And if you think, we can divide the h into both pieces. So we're going to get the limit as h approaches 0 of x plus 1/2 h. And then using our rules of limits, if we substitute 0 in, this guy here just becomes 0. So what ends up happening is the idea here is the limit as h approaches 0 of x is just x. So what that tells me is that f prime of x is equal to x. So what that is that's the derivative. That's how I figure out the slope. So I could realistically find the slope of that parabola at any point, and I could do that by using that sort of formula. So that's our idea of what a limit is, okay? So what we're really thinking about is this, is that if I all of a sudden had a curve here and I was trying to figure out what is the slope at various points. So again, let me just bring this down here so we can see a little closer. So what this means is this. So we got 1, 2, 3, 4, 1, 2, 3, 4. And again, if we have 1/2 x minus 1, so let's say that's 1. And what we're trying to do is we're trying to find what is the slope when x is -2. So when x is -2, we're going to go ahead and we're going to be looking like right about there. That's when x is -2. We would find out that the slope of this line is -2. When we're at 0, we'd find out the slope is 0. That's this horizontal part right down here. And then if we were looking at f prime of 2, what it's saying is like right about here, what we'd find out is the slope is 2. It's just our way of figuring out slopes at various points along the curve. Like I said in the class on Wednesday, when we had a line, it's the slope remained constant the entire line. When we deal with curves, the slope is actually going to change as we kind of work our way through the problem. So when we look at these problems, what we really need to do is we need to kind of understand that this is the process that we're going to undertake to figure out slopes. Now, what I want to tell you is there's another way that we can actually kind of look at a derivative. And let me show you this other method of looking at a derivative. And that's going to be this, that if I'm looking for the derivative at a point, I'm going to take the limit as x approaches that point. And I'm going to say f of x minus f of c. And I'm going to put that whole thing over x minus c. So the only difference here between what we did before is this guy right here. We basically said, well, let's just go ahead and say that at h equals x minus c. So what we're going to do there is we ended up making this guy f of x plus h. I'm sorry, f of c plus h, f of c plus h minus f of c all over h. That's just another way of doing it. But this is just an alternative definition of it. So again, where would you see a problem like that? You'd see a problem like that if I was trying to find, let's say I told you that f of x equaled 3x squared. And I want to find the derivative of this guy at 2. What I'm going to do is I'm going to go ahead and use this process here. What I'm going to figure out is I'm going to say, well, f of x is 3x squared. F of c, in this case, is going to be f of 2 is 3 times 2 squared. So that's 3 times 4, that's 12. And I'm going to look at this bottom, x minus c, which is then going to be x minus 2. And to do this derivative, I would do f prime at 2 is going to equal the limit as x approaches 2 of 3x squared, that's my f of x, minus 12, that's my f of c, all divided by x minus 2. And this goes back to what we just took our test on. If you actually look at this, you can't plug the 2 directly in, so we got to do our little factoring thing. This becomes 3x squared, 3 times x squared minus 4 over x minus 2. This becomes 3 times x minus 2 times x plus 2 over x minus 2. What we find out is that this limit, it's going to be the limit as x approaches 2 of 3 times x plus 2. And again, this is this idea of where we can go ahead and do our calculation. We can go ahead and plug the 2 in here. So what we do is plug in the 2 here. We do 3 times 2 plus 2 is 4. That gives me a 12. So that tells me that the limit as this guy approaches, the slope of this curve at 2 would be 12. Okay, so that's one way to do this. Again, this is just an alternative method of doing the same problem. What we did before was we figured out a general form of it. So like this guy, we figured out the general form, and the general form was f prime of x is x. The derivative, the slope of my curve at that point is x. This one actually goes directly to the answer. So it's saving a substitution step, but changing the work at the beginning. So let me just go through one more just so you can kind of see what I'm talking about. So what I'm going to do again is now I'm going to look at f of x equals 5x plus 1. And again, I want to find what is the slope of this guy at -2. I'm sorry, 2. What is the derivative of this guy, 2? So again, what I want to do when I look at this is, I'm looking at f prime of 2 is going to equal the limit as x approaches 2 of f of x minus f of c. And that whole thing is divided by x minus c. So in this case, all those c's are 2. So that's a 2, and that's a 2. And what I'm going to do is I'm going to say f of x equals 5x plus 1. F of 2 is going to equal 5 times 2 plus 1, which is 11. And now what I'm going to do is I'm going to go ahead and substitute things in, see what I get. So in this case, I'm going to say limit as x approaches 2 of 5x plus 1 minus 11 all over x minus 2. So again, if you notice this one, this is another one of these ones where I have to simplify or just reduce it so I can actually take the limit because it makes the denominator 0. So again, f prime at 2. So I'm going to say f prime at 2, the limit as x approaches 2, 5x plus 1 minus 11 over x minus 2. That is 5x minus 10 over x minus 2. And in this case, 5 times x minus 2 over x minus 2 cancels out. That tells me that this limit is 5. So that slope is 5, but we should know that anyway, because the slope of a line is the number in front of the x. So this tells me pretty much if I did this for any number on this 5x plus 1, it'd always be 5, because again, we got our line, and our line basically 5x plus 1 looks like that. Slope is 5 the whole time. So that's our idea of that. So what we're going to do now is talk about some other ways that this could come into play. And what I want to do is see if this is actually going to work. So I want to go ahead and drag this guy over here. And I want to look at this slide right here and kind of talk about the idea of this slide. This slide is another way of finding a derivative. What I want you to see is this one saying, I'm tracing something in time in minutes up top. I'm tracing the degrees in Fahrenheit in the bottom. So this is kind of my X in the top. This is my Y at the bottom. What I'm trying to do is I'm trying to figure out what is the derivative or what is the slope of this curve at 5. And what I want you to notice here is when we actually look at this slide, we notice we have 0, 1, 2, 2.5, 4, and 6. We're trying to get close to 5. Well, the best case we have here are instances where we got 4 and 6. So we know that when t equals 4, W of 4 is equal to 186. We know that when t is 5, W of 5 is equal to, when t equals 6, W of 6 is going to equal 212. So I'm going to kind of slide back to the dock camera. So bring this back over. And what we'll see is that, again, t of 4 is 186, t of 6 is 212. And what we're trying to basically do is, if you think about this again, we're trying to think about this. We're dealing with 1, 2, 3, 4, 5, 6. So we're saying at t of 4, this guy's at 186. So this would be 4, 186. And we're looking at 6, and 6 is 212. 6 and 212. And here's the deal. If you were to think about this as a line, we don't know what the curve looks like. We could figure it out if we wanted an equation. But what we're going to do is we're going to do our best guess here. And think about that as a slope. And our whole goal is to try and get things down to looking like a line. So in this case, if you want to think about it, this becomes your change in y over your change in x, your delta y over delta x, your y2 minus your y1 over your x2 minus your x1. Basically, the average rate of change between the two. If you think about it, the average of 4 and 6 is 5. And now I can figure out what the average rate of change is there. So what I'm going to do is I'm going to do 212 minus 186 over 6 minus 4. So 212 minus 86 is going to give me 26. And what's going to happen on this one is we have over 2. So that's going to tell me that the slope of this guy is roughly 13. So what that says is that every time I go up 1, I'm going to go, every time I go right 1, I'm going to go up about 13. So again, this guy would be, a good estimate would be 199, because again, I'm going up 1, 4. There's my change in x down below. The change in y is 13, so I went up about 13. So if you were asking me, what do I think the value is at 5? I would tell you that the value is at 5. If I made this prediction, it would be about 199 degrees Fahrenheit. So that is our idea of kind of using derivatives in practice. The other stuff is going to be really a lot of review, and I'm going to, like, the slides are up there. I'll let you kind of go through this. I'm going to link to some videos as well. But really what I want you to do is I want you to come up with the idea of like how we write slopes, how we write tangent lines, like how do we go about doing it. So again, what I'm going to do is say if I had the point 4 comma 1 and I had a slope of -2. So I have the point 4 comma 1 and I have a slope of -2. What would the equation of the line be? Y minus y1 equals m times x minus x1. And what that means is if I went ahead and figure that out, plug in my numbers, there's my x1, there's my y1. So this would be y minus 1 equals -2 times x minus 4. So there's my equation of the line. This is the equation of the line. So again, that's just a little bit of a review from your Algebra 1 days. Now I'm just going to build off of that. And what I'm going to say is this. I want you to go ahead and write the equation of the line. I want to write the equation of the line that is the tangent. So the tangent line, that's the new piece. My equation is f of x equals 2x squared plus 1. And I want you to do it at x equals 1. So again, there's a couple ways to do this. You could go about and figure out the overall limit. Like I could go about and figure out what is the overall limit of this. But what I need to do is I need to figure out the slope of it first. So I need to figure out the slope of it first. So, or actually the first thing I'm going to figure out is the point. If I plug 1 into this machine, 1 squared is 1, 2 times 1 is 2, 2 plus 1 is 3. So I know that this curve goes through the 0.13. So I got my x1, I got my y1. So now what I'm going to do is I'm going to do that f prime of 1. It's going to equal f of x minus f of c over x minus c. Or in the case of this problem, it's going to be, the limit as x approaches 1 of f of x minus f of 1 all over x minus 1. This will give me my slope. What I'm going to do is I know what f of x is, so I got the limit as x approaches 1 of f of x, which is 2x squared plus 1. I'm going to subtract what f of 1 is. Well, I figured out what f of 1 is. F of 1 is 3. I'll put that whole thing over x minus 1. So now this becomes the limit as x approaches 1 of 2x squared plus 1 minus 3 over x minus 1. And if I keep simplifying this, this becomes 2x squared minus 2 over x minus 1, which becomes 2 times x squared minus 1 over x minus 1, which becomes 2 times x plus 1 times x minus 1 over x minus 1. Cancels those out. So I know that this guy ends up becoming the limit as x approaches 1 of 2 times x plus 1. So now what I know is I can actually figure out the slope. Remember, the rule is always try substitution first. So if I substitute a 1 in for the x, I get 1 plus 1 is 2. This guy's 4. That's my slope, if you will. So I've got a 0.13. I've got a slope of 4. So what this ends up becoming is y minus 3 equals 4 times x minus 1. And that's the equation of my tangent line. And we could repeat this process many times if we needed to. So hopefully that helps a little bit. I'm going to also link some AP Classroom stuff here that I encourage you to watch, because I think that really you'll get something out of those AP Classroom videos. And I'll be back in the classroom on Wednesday. So I'll see you all on Wednesday. And email me if you have any questions. I hope this helped, and have a nice day.